Computer Network. Here I have 10 questions in this video. We will discuss each and every question in detail. So let's see the question. This is the question number first. Consider the following statements with respect to network security. With respect to what? Network security. Read the first statement. Message confidentiality. So first we need to understand what is confidentiality. Confidentiality means if you want to secret something, or you can say that if we want what? Privacy, like this. If two peoples are what? Privacy, this is what confidentiality means. You want to secret the information between these two peoples only. Okay, you want to share this information between these two peoples only. So like this you can consider. Confidentiality means something is secret, something is privacy, like this. Message confidentiality means that the sender and receiver expect privacy. Yes, as I told you earlier, yes, privacy. Yes, this statement is correct regarding the network security. Come on the statement second. Message integrity. So first I want to tell you what is message integrity before read this statement. Message integrity is what? Something, suppose sender is sending something to the receiver, then during the transmission message need not to be altered. Message need not to be altered means message need not to be changed. Message आपका change नहीं होना चाहिए. Okay, means whatever you are sending, whatever sender is sending, received by the receiver, during the transmission it is not going to what? Change. This is what message integrity. Read the statement now. Message integrity means that the data must arrive at the receiver exactly as they were sent. Yes, as I told you, whatever sender is sending, receiver need to receive that message. Okay, means no need to change the message during the transmission. That is what message integrity. Yes, right. Yes, this statement is also right related to network security. Come on the statement third. Message authentication means is the receiver is ensured that the message is coming from the intended sender. Intended sender means is what? Receiver need to verify. In message authentication, receiver need to verify means the message which is coming from the source is a verified source or not, means from which source I want to receive the message, the source is a intended source or not. So yes, this is what message authentication. First receiver verifies whatever message he or she is receiving, that message from the intended sender or not. Yes, this is what message authentication. Yes, so these three statements are correct. These three statements are correct in terms of what? Network security. Okay, so it is asking you what? Which of these statements is / are correct. मतलब इनमें से कौन सा statement सही है. So as I told you, all the three statements are correct according, or you can say that in terms of network security. So only first and second no, all the statements are correct. Only second and third no, only first and third no. As I told you, all the statements are correct here. So option D, yes, first, second and third, all the statements are correct in terms of network security. So option D is correct here. A very good question. So our NIC live classes batch is going on. If you want further information, we have one course also, that is what video on demand. So if you want to get the further information, then you can visit our nimbus.org.in, okay, for more information. This is the question number second. Let's read the question. Anarkali digitally signs a message and sends it to Salim. Salim requires which pair of keys for decryption? So first I want to tell you what is digital signature. What is digital signature? How anarkali can form a digital signature? Okay, so suppose we have a message M. Suppose we have a message and we denoted message by M. So to form a digital signature, first we need what? First we need what? Hash function. First we need what? Message digest, you can say that. First we need what? Message digest. So when you will apply what? How you can get the message digest? How you can get the message digest? So the very first thing which we need to create digital signature is what? Message digest, and that you can denote it what? HM. So you need to apply, how you can get the message digest? You need to apply what? Hash algorithm or hash function, you can also, on the original message. When you will apply what? Hash algorithm on the original message, then you will get what? Message digest. Once you will get what? Message digest, then you can form what? Digital signature. You can form what? Digital signature. So digital signature equal to what? Digital signature. How you can form digital signature? You need to encrypt. You need to encrypt this message digest by using the sender's private key. You need to encrypt this message digest by using the what? Sender's private key. Sender's private key, comma this HM, comma this HM. So you can send this digital signature along with the message. So I want to tell you one thing. At the sender side, which pair of keys you required? At the sender side, which pair of keys you required? This is what? Sender side. So at the sender side, which pair of keys you required? So you required what? Sender's private key followed by what? Receiver's public key. Okay. So pair of keys required at the sender side is what? Pair of keys. So I am giving you this extra information. So pair of keys required at the sender side is what? Sender's private key. Sender's private key followed by receiver's public key. Receiver's public key. So these pair of keys we required at the sender side. And what about the receiver side? Means Salim is receiving the message. So Salim requires which pair of keys for decryption? So as we know that in digital signature, first it will decrypt the message and also verifies whatever message it is getting or he or she is getting, receiving from the intended sender or not, means receiving from the valid source or not. Yes. So at the receiver side, means for the decryption, at the receiver side you also needs two pair of keys. What is pair of keys you need? Pair of keys you need. So to decrypt, to get the original message or to decrypt the message, it needs what? Its own private key. Receiver needs what? Its own private key, and followed by what? Sender public key for the verification, and followed by what? Sender's public key for the verification, means whatever he or she is getting from the valid source or not, getting from the intended sender or not. Okay. So here it needs what? Own private key, receiver private key, you can say that, own private key, followed by what? Followed by public key of sender, public key of sender for verification of message. You can say that what? Message authentication for. Okay. So it is asking you like this. Here Analkari is what? Sender, and Salim is what? Receiver. So Salim requires which pair of keys for decryption? As I told you, Salim requires its own private key and public key of Anarkali, and public key of sender. Sender is what here? Anarkali. Okay. So own private key followed by Anarkali's public key. Yes. So option A is correct here. As I told you here in detail, It's requires Salim requires what? Salim is a receiver. Salim requires its own private key and followed by Anarkali's public key. Anarkali is what? Sender public key. Okay. Option B is saying what? Directly you can get what? Option A. Anarkali's public key followed by own public key. No. Own private key followed by Anarkali private key. No. And option D is by default wrong. So which option is correct here? Option A is correct here. So you can remember these points. Sender side we need two pair of keys. Sender's private key followed by receiver's public key, and receiver side you also need two pair of keys. Receiver's own private key followed by public key of sender. So this is the extra information which you can get from this question. So let's see the question number 3rd. What it is saying and what it is asking from you. Very good question. Read the question. Identify the correct sequence in which the following packets are transmitted on the network by a host when a browser requests a web page from a remote server. Okay, assuming remote server means is what? Over a distance. Server is present over a distance. Assuming that the host has just been restarted. So to give the answer of this question, we need to understand the connection. Means how we can connect one network to the remote network, or our network to the remote server. We need to understand this first. So here I am going to take an example, and through that example you are able to understand which sequence is correct here. Okay. So suppose I have a network in India. And I want to connect the India network with USA server, or you can say that with USA network. Simple. Suppose here we have a host HA in India, and here a process is going on. What P1 you can say that, and we want to connect this host with this server, means this network. Suppose here we have another host, that is what you can denote it what? HB. Okay, host B, and here another process is going on. So if we want to connect this network with this server or this network, then what we need to do first? So first we need to open what? Browser. Okay, first we need to open what? Browser. On browser we need to give what? URL address, like www.nimbus.org.in. Okay, so this URL address taken by what? DNS, domain name system. Okay, DNS, domain name system, it's a protocol. This URL address taken by DNS, and it will produce what? It will produce IP address. IP address from this URL address. So it will produce you what? IP address from this URL address, and IP address is a 32-bit long field. And here in IP address we have two parts. First one is what? Host ID, or you can say that first one is what? Net ID. Very simple. Through this process you can understand which answer is correct, which option is correct here. And second is what? Host ID. So net ID is used to connect this network to this network. Okay, and host ID is used to connect this host to this host. Okay, host ID is used to connect to this host. Okay, very simple. So after the connection, whatever you want to access from this server or this network, you can access. Means you can send what? HTTP request. You can send, browser can send what? HTTP request, and in reverse it will get what? HTTP response if the matching is found in the server or in the network. So which sequence is correct here? First you are needing what? DNS query to convert the URL address into IP address. After that, what you are needing? What? TCP connection. Means you are needing what? Connection. Okay, and after that, whatever, when connection is established once, then whatever you want to access, you can access through the HTTP request, get request. Okay, so this is the procedure. Let's see which sequence is correct here. Very simple question. Okay, and need to understand this point. So HTTP get request, no, first we need what? DNS query. HTTP get request, then DNS query, then TCP connection, no, first we need what? DNS query. You can understand from here, very simple, from very simple way. Second statement is what? DNS query, comma, HTTP get request, comma, TCP SYN, no, DNS query, yes, first we need DNS query, but after DNS query, what we need what? Connection. We need what? Connection between India network to USA server or USA network. Okay, so after DNS query, we need what? TCP connection. That's why this sequence is also wrong. Come off in option C, DNS query, comma, TCP SYN, yes, after DNS query we need what? TCP SYN, we need connection, and after connection we can get anything through the HTTP get request from the server or from the network. Yes, so this is the correct sequence here. This is the correct sequence here. You can identify this through this diagram. Very simple way you can identify. So option D is also wrong. First you need what? Connection? No. First you need what? DNS query to resolve, to give you what? IP address. So that's why it's also wrong option. So which option is correct here? Option D is correct here. Very good question. So need to understand this question first. So this is a good question. This is the question number 4. Let's see what it is saying. Means what is the question? What is the question here? Let's see. Which of the following is not needed by an encryption algorithm used in cryptography? Used in cryptography. And which of the following is not needed by the encryption algorithm? Means when you are going to do what? Encryption of the masses or plain text, then which of the following you don't required at that time? Means encryption algorithm don't required. Okay, so very simple answer of this question, and they can ask you that types of question, logical questions. Okay, so here for the encryption we need what? Key. Yes, we need pair of keys, either it is a public key or private key. We need what? Key. Yes, we need key. We also need what? Message. ओके जब तक आपके पास मैसेज नहीं होगा आप इंक्रिप्शन किस पे करोगे? यस, वी ऑल्सो नीड्स व्हाट? मैसेज. सो कैन वी नीड यूजर डिटेल्स? इसकी जरूरत हमें पड़ सकती है क्या? हमें इसकी जरूरत पड़ेगी यूजर डिटेल्स की ड्यूरिंग द इंक्रिप्शन. सो इंक्रिप्शन एल्गोरिथम नीड्स यूजर डिटेल्स. सो एज वी नो दैट वेरी वेल, we require what? Key for the encryption. Yes, we need key, either it is a public or private key. Yes, we require what? Message. Yes, we require what? Plain text. And we require user details for the encryption. No, we don't require the user details for the encryption. So here it is asking you not needed, not needed by the encryption algorithm used in cryptography. So clearly you can give what? Answer C. Clearly you can see, give what? Answer C. So that types of questions they can ask. They can ask you logical questions they can ask you. So let's see the next question. This is the question number 5th. The value of 3 की power 93 mod 7 is? Mod 7 is. So this is also a good question, and they can ask you that types of question. So how you can calculate 3 की power 93 mod 7? We have a little Fermat's theorem. We have a what here? Little Fermat's theorem. And what is little Fermat's theorem? A की power p minus 1 mod p equal to 1, or you can write it like this: a की power p minus 1 equal to what? 1 mod p. So both the terms are what? Equal. This is a little Fermat's theorem. So take the expression. Expression is what? 3 की power 93 mod 7. So I am going to compare this with this one. Okay, so here a equal to what? 3. P equal to what here? P equal to here is what? 7. P equal to here is what? 7. And a equal to here is what? 3. So I am going to apply this p value here in this little Fermat's theorem. So what you are getting from here, हम लोग को क्या मिलेगा, what we are getting from here, a is nothing but what, 3, 3 की power p minus 1, p minus 1 is what, 6, okay, mod p is what, 7, p is what, 7, okay, so 3 की power 6 mod 7 equal to what, 1, 3 की power p minus 1 is what, 7 minus 1 6, 3 की power 6 mod 7 equal to what, 1, so we need to divide this into factor, so 16 16 6 is 96, okay, 15 6 is how much, 15 6 is about 90, 15 6 is about 90, so you can break it like this, 3 की power 6 mod 7 की whole power is what, 15, की whole power is what, 15, like this, okay, dot, and after 90, 56 is about 90, after 90 what is it is, what is remaining here, 3 की power what, 3 mod 7, 3 की power 3 mod 7, and clearly you can get what, 3 की power 6 mod 7 equal to what, 1, so when you will put what, 1 here, 1 की power 15 is what, 1, so 1 dot 3 की power 3 means 3 3 is 9, 9 3 is 27, so 27 mod 7, so 7 3 is how much, 7 3 is 21, so what is the remainder, 1 dot 6 equal to what, 6, so the answer means the value of this whole expression is what, 6. So when you will go through this little format theorem, then that types of question is very easy for you, understand guys, so that types of question they can ask you, and that types of question they already asked in GATE and other exams, so they can ask you that types of question in your scientist B or technical assistant post also, so need to remember this, what, need to remember this little format theorem, okay, whatever expression is given, take the value from there p and a, and apply this little format theorem here, you will get what, answer 6, so 5 no, 5 no, 6 yes, option we are getting what, 6, so which option is correct here, option B is correct here, C no, D 6, okay, here 2 times 6, so you can change it what, 8, 8 no, 8 is also wrong, so which option is correct here, B option is correct here, okay, means 6 is your final answer. Let's see the next question. Let's see question number 6. Read the question. Assume that source S and destination D are connected through two intermediate routers. These are the routers. Yes, fine. Level R. Determine how many times each packet has to visit the network layer, okay, network layer and data link layer during a transmission from S to D, okay. So this is a good question, you can identify this through a diagram like this. I am going to give the diagram here. So suppose this is what, say sender is here, and sender need to visit all the 7 layers, okay, so sender need to visit all the 7 layers, so what, P, D, N, T, S, P and this A, okay, and your packet starts from here, your packet starts from here, yes, it need to visit all the 7 layers. Here what we have what, router, here what we have, router, so router visits, we use router at the network layer, yes, very simple, so it P, D and N, here packet will visit only the 3 layers of the OSI model, means we use router what, हम लोग router कहाँ use करते हैं, network layer पे, we are going to use router on the network layer, that's why. So when packet is come back like this, it will go like this and again come back like this, so again what we have, the router, so here it also visits 3 layers only, P, D and N, so your packet go like this and come back like this and go to the destination, so at the destination it need to visit all the layers, P, D, N, T, S, P, A. P means is what, physical, D means is what, data, and N means is what, network layer, T means is what, transport layer, S means is what, session layer, P means is what? Presentation layer. A means is what? Application layer. So when your packet reaches here, and your packet delivered here, okay, destination at the application layer, your packet is delivered, okay. So it is asking you how many times a packet is going to visit during the transmission, network layer and data link layer. So here you can clearly see from here, one time packet is going to visit data link layer here, one time packet is going to visit data link layer here when it will go above like this, one time here, when it will come back, one time here it will also visit, when it will go here, one time it will visit data link layer here, and when it will come back, then it will also visit data link layer here, okay. When it will go, when it is delivered, okay, so one times it is going to visit what? Data link layer here. So how many times packet is going to visit the data link layer during the transmission? Very simple answer, 1 2 3 4 5 6. How many times? 6 times. So data link layer it is going to visit how many times? 6 times. Now need to calculate how many times it is going to visit what? Network layer. Very simple. So one time it is going to visit network layer here, and only one time it is visiting here, okay, and one time it is going to visit here, and one time it is going to visit here. So how many times it is going to visit what? Network layer? Only 4 times. 1 2 3 and 4. So network layer it is going to visit how many times? Very simple answer. Network layer how many times? 4 times. Okay, let's see which answer is correct here. Let's see which answer is correct here. Network layer 4 times, yes, network layer 4 times, and data link layer 4 times, no, data link layer how many times? 6 times. So that's why this option is wrong. Network layer 4 times, yes, and data link layer 3 times, no, data link layer is what? 6 times. Network layer is 4 times, yes, fine, and data link layer is what? 6 times, yes, this option is correct. Clearly you can see from here, data link layer how many times? 6 times, and network layer how many times? 4 times. So yes, option C is correct here, and option D is also wrong. It is saying network layer 2 times, no, network layer 4 times, okay. So here you can see clearly option C is correct here. Let's see the next question. This is the question number 7. What it is saying and what is given in the question, let's see. Read the question first. In the network 193.162.68.240/28, the 4th octet in decimal of the third IP address of the network which can be assigned to a host in the network. It is asking you the last octet value when you are going to assign the third IP address, okay, third IP address to any host. Very simple. So it is what? This notation is what? This notation is a CIDR notation, means classless interdomain routing notation, okay. So clearly you can take this one 193.162.68.240/28. So as we know that in CIDR notation, whatever is given in the after the slash, that is called what? Prefix of network ID. That is, or you can simply say that it was network ID. So that is what net ID is here. So this is also known as what? Classless addressing, IP addressing. So net ID is equal to here is what? 28. So how you can calculate what here? Host ID. So very simple. To calculate what? Host ID. So total IP address how many bits long? 32 bits long, because we have 4 octets and every octet can contain only 8 bit. So 32 minus 28, you will get what? 4 host ID bits, okay, 4 host ID bits. These are the net ID bits and these are the host ID bits, okay. So from this given IP address, CIDR notation, given IP address, a classless IP address, we are getting what? 4 host ID bit only, okay. So from the last octet we can get what? Host ID, we can get what? Host ID bit. So need to represent only this one into binary, okay. No need to represent this one into binary, need to represent only this one into binary, because we have only 4 host bit. So we can get 4 host bit here from this last octet, Okay, so need to represent this 240 into binary. What is the 240 binary of the 240? When you will put first 4 bit is what 1 and the remaining 4 bit is what 0. This will give you what 240. Understand? Yes. So how many bits here we have? What host bit? This host bit. So to calculate the IP address that we can assign to a host in classless IP addressing, we need to make a combination. So here we, how many bits we have here? 4 bit we have. Okay, so through the 4 bit how many combinations we can make? 0 0 0, okay, 0 0 0 1, 0 0 1 0 and so on, and the last combination is what 1 1 1 1. But as you know that due to directed broadcast address, okay, we cannot take this 0 0, all 4 bits of the host ID is what 0 0 0, and we cannot take all 4 bits of the host ID is what 1 1 1, because what is DBA? Suppose you are sending a packet or frame to a specific destination, then you need to put all host bit, you either 0 or 1, either 0 or 1. This is a directed broadcast address. So we are not going to take this 0 0 0 and 1 1 1, remaining we need to take, remaining we can take. So it is asking you what third IP address. So how you can make what third IP address here? So when you will put what? When you will put 0 0 1 1, when you will put what 0 0 1 1, this will give you what 1, this will give you what 2, this will give you what third. That's why it is a third IP address to a host. So when you will put these 4 bits is what 0 0 1 1, then you will get what third IP address of the network, which can be assigned to a host, which you can assign to a host. Very simple way. So when you will put is what these bits are not going to change, because these only bits are the host bit. So at the place of host bit we can put this third. Okay, we can put this third host bit 0 0 1 1. So what is the value of this? This is what 240 and this is what 3. So this will give you what 243. This will give you what 243. Understand? This will give you what 243. So this is the last octet value of the third IP address that you can assign to a host in the network by using what classless interdomain routing, or by using what classless interdomain routing. Yes, good. So 243. So which option is correct here? 244 no, 240 no, 243 yes. Option C is correct here. We can clearly see from here the last octet value is what 243 in the third IP address, which you can assign to a host in the network. Yes, 243 is correct answer. I hope you understand. This is a good question. Let's see the next question. Question number 8. What it is saying? Read the question carefully. Consider different activities related to email. Okay, related to what? Email. This is also a good question. They can ask that types of questions. M1 is what? Send an email from a mail client to a mail server. So as we know that to send a email, which protocol we need? We need simple mail transfer protocol. SMTP means we need what? SMTP is used to send what? Electronic mails. Okay, so yes, here what, which protocol which we need? SMTP, simple mail transfer protocol. Okay, simple mail transfer protocol is the what? Application layer protocol, and it is used to send what? Electronic mails. Come on M2, download an email from mailbox server to a mail client. So as we know that to download the emails from the mail server, we have two protocols. First one is what? POP, and second one is what? IMAP. POP is what? Post office protocol, and IMAP is what? Internet message access protocol. So what is the difference between these two protocols? Listen me carefully. This is extra information for you all guys. Okay. So POP is what? Post office protocol. So POP allows you to see the content of the message before download the message on your desktop. This functionality provided by what? POP. But IMAP, POP is not going to provide, POP is not going to provide this functionality. POP does not allow you to see the content of the message before download the message on your desktop. ये आपको अलाउ नहीं करती है. And what is IMAP, Internet Message Access Protocol? It allows you to see the content of the message before download the message on your desktop. This is the difference between POP and IMAP. Listen me carefully again. POP doesn't allow you to see the content of the message before download the message on your desktop, but IMAP provides this feature. Means it provides this feature. Okay. So here we can use anyone. We can use either POP or IMAP. For download the message, we can use any one protocol. What is activity M3? Checking email in a web browser. So checking email in a web browser, you need which protocol? HTTP. You need which protocol? HTTP, Hypertext Transfer Protocol. And Hypertext Transfer Protocol we used to access anything from the word byte. Okay, yes, fine. So let's see which option is correct here. M1 is using what? HTTP? No. M1 activity is going to send what? Electronic mail, and to send the electronic mail we need what? SMTP, not HTTP. So directly we can cut that option. M1 SMTP, yes. M2 FTP, no. To download the file we use what? File transfer protocol, but to download the emails we can use either one. Okay, protocols means we can use what? POP, or you can use what? IMAP. Yes. So that's why here we are using M2 in FTP in M2 activities. That is also a wrong option. M1, yes. SMTP, yes. M2, yes. It is going to use what? POP, post office protocol, to download the message. Yes. M3 is what? HTTP, yes. So which option is again correct here? C option. Option D is using what? POP. No, POP we use to download the message, not to send the message. So this is also wrong option. So directly which option is correct here? Option C is correct here. Okay guys, let's see the next question. This is the question number 9. So if you want to join our NIC batch for the live classes, or if you want what video, means video on demand, then you can visit our website nimbus.org.in for further information about the course detail, about the courses. Let's see the question. The total number of keys required for a set of 6 individuals to be able to communicate with each other using secret key and public key crypto systems. So for that directly we have the formulas. So when you are using what? Secret key crypto system or private key crypto system, then you have how many? Then you have number of keys how many? N minus 1 divided by 2. When you are using what? Secret key. When you are using what? Secret key. N equal to here is what given? What? 6. Put it here. So N is what? 6 into 6 minus 1 divide by 2. So 6 into 5 divide by 2. 2 3 is 6. How many? 15. How many keys? 15. Okay. And for the public key crypto system, as we know that each individual requires 2 keys. Okay. So we have directly formula for the public key crypto system also. What? 2n, and n is here is what? 6. So 2 into 6, how much? 12. So for the secret key you need what? 15 keys. For the public key crypto system you need what? 12 keys. If we have n individuals in a set and they want to communicate by using secret key and public key, when they want to communicate by using secret key, they require what? 15 keys. And when they want to communicate by using the public key crypto system, they require what? 12. Understand you all? So let's check the options. 6 and 15. 6 and 15, no. 30 and 60, no. 15 and 6. 15 and 6, no. 15 and 12, yes. 15 and 12. So for the public secret key we are needed what? 15, and for the public key crypto system we needed what? 12. Yes, option D is correct here clearly. Option D is correct here clearly. This is also a good question. So you need to remember this formulas also. They can directly ask you this formulas or this formula, and they will ask you like this question. Let's see the question number 10. The full form of ICANN. ICANN. Okay. So the full form, what first we need to understand what is the ICANN. So ICANN is a American non-profit organization that is responsible for the maintenance and procedures of various databases related to namespaces and numerical spaces of the internet, related to namespaces and numerical spaces of the internet. Okay. So I am going to repeat again this statement. ICANN is what? Is a American non-profit organization that is responsible for maintaining the what? Namespaces and some other spaces, some other numerical spaces for the internet, for the internet. Yes. So what is the full form of this ICANN? Internet Corporation for Assigned Names and Names. No, wrong option. Institute of Corporation for Assigned Names and Numbers. No, wrong option. Internet Connection for Assigned Names and Number. No, wrong option. So what is the full form of ICANN? Internet Corporation for Assigned Names and Number. Yes, here option D is correct here. Here option D is correct here. So these are the 10 questions which most expected, means which they can ask again. Okay, they can ask in your NIC exam. So